Imagine a world where you're not surrounded by air. Without the oxygen in the air, we wouldn't survive for very long. The same goes for aquatic animals. So let's turn to our underwater friends, Bubbles and Pepper.
We need oxygen too.
But where do we get it from?
The answer is from the water, because the water actually already contains oxygen.
Dissolved oxygen. But what is dissolved oxygen, you may ask?
Dissolved oxygen is what it sounds like. It is simply the concentration of oxygen dissolved in water.
But how does oxygen even get in the water? Let's try to show you by this experiment.
Oxygen molecules and water molecules evenly mix together.
Just like the way water mixes with sugar. There are two main sources from which oxygen can enter a body of water.
One way is from the atmosphere. Oxygen molecules make up about a fifth of our atmosphere and are constantly bumping into and entering the water. Even more oxygen enters through the process of photosynthesis.
We know photosynthesis as the way plants produce their food. However, there are many more photosynthetic organisms, from green bacteria called cyanobacteria to little phytoplankton with crazy names.
When they undergo photosynthesis, they produce oxygen, which then goes into the water.
Ugh, thanks, but what happens to all this dissolved oxygen?
Remember, like us, the other living things, animals, plants, phytoplankton, and bacteria living underwater also need oxygen to live. Furthermore, oxygen molecules are continually shuttling back and forth between water and the atmosphere.
But note that there's not always at least some amount of oxygen that stays dissolved. That amount depends on water conditions, like how many pollutants are in that body and temperature. Oxygen always moves into a roomier atmosphere.
So the more contaminants like plastic clogging up our estuary, the less room for oxygen in the water. Less oxygen in water means less
fishies like us!
What about temperature?
Well, when molecules heat up, they move around like crazy. This vibration makes it easier for oxygen to escape the water. Let's show you in another experiment. When you pour cold soda, the bubbles try to stay in the soda like dissolved oxygen in cold water. See them going back in? But when you pour warm soda, all the bubbles try to escape. So basically, all that Gibber means is the more cold water, the more necessary gases can be retained. So to recap, dissolved oxygen is very important for our survival in this environment.
We need high oxygen and less pollution to keep our species alive. Thanks for watching!